Sorry, I got disconnected. I don't know how. So as I was talking to you that we are working on this project. There is a team of 9 people. With me is Professor Preeti Khanna Madam, who is an expert in computer vision and artificial intelligence. Then we have Dr. Kusum Kumari Bharti, who is a data scientist, expert in data science and AI. Dr. Neelam Dayal is also an expert in IoT and related applications. And from IIT Guwahati, we have Dr. Gaurav Trivedi, who is an expert in VLSI design and other related areas. From Nepal, we have Dr. Gajendra Sharma from Kathmandu University, Dr. Surendra Gautam from Tribhuvan University. From Bhutan, we have Dr. Tulsi Gurung. From Bangladesh, we have Dr. Muhammad Yunus Ali from Bangladesh University of Engineering and Technology, and Dr. Alim Al-Islam, who has also joined our team. So we have in this team of 9 people who are supporting the very noble cause of empowering girls to reduce the gender gap in IT-enabled sector. Under this project, we are having 2 types of programs: capacity building programs for building the capacity of teachers and institutions in niche areas of IT and IT-enabled sectors, and also the skill development program for students. These capacity building programs, this is the second one in the row. The first capacity building program was held in December last year, and it was focused on ICT tools for teaching and research. This capacity building program is Introduction to Artificial Intelligence and Machine Learning. And the first, just a minute, please allow me to stop because, and one thing I would expect from the participants is that this is a program having large number of participants. So as we know that if I give you enough privileges so that you can also participate in interaction, debates, discussions on certain topics, emerging topics in AI, that freedom should not be misused. For example, I recently saw Akash Sahu was annotating. So, my dear participant, please behave in this program because we want to learn together. If we find some kind of anomalous behavior from some participant, we will be compelled to remove them. So may I request you to please use your privileges with great wisdom so that you can also get an opportunity to learn with us. So my request to all the participants is to maintain dignity of your own dignity so that you can participate here. With this, I give it to Dr. Preeti Khanna Madam, who is the co-coordinator of this program, to tell more about the program itself. Thank you. Preeti, you are not muted. You are muted.
Oh, I'm so sorry. A very good afternoon to all of you. And so Madam has introduced you about this program. And now this course, AI and machine learning. So as we all know that we are now living with this, word we can say artificial intelligence. So whether we saw our mobile in the morning or news or like we are doing any work here. So everywhere AI is everywhere now. And in every application we are seeing it. And so this is the very apt course at this moment because we because the young people like you and those who are working in the field of research, we need the tools so that we can develop the new tools for our applications in which we are working. And with this thought, we have decided to launch this capacity building program on AI and ML. And so this program is somewhat, if you have gone through the what topics and what the curriculum we have decided for this is slightly different than the conventional machine learning or deep learning program. Here, we wish to give you the it has started with the view of, because now what artificial intelligence is started in the beginning and what artificial intelligence we are looking at this day, there is a, I mean, huge we can say it's a long journey and a huge difference over the thing. So we thought that let us we take you from that past to this present, so that you may visualize this journey, and in this journey how the progress has been made, and that is how the different topics have been evolved. So we'll take you towards I mean, from AI, machine learning, deep learning, so from, I mean, till this object detection and the vision transformer, who are the state of the art nowadays for various applications. You can see the research papers, people are using it. So we have tried to cover everything. And another good aspect of this program is the hands-on sessions. As you can see that today, of course, we do not have, but from tomorrow onwards, we will be having hands-on sessions where you can do the things on your own. And I would request all of you to please, I mean, attend those sessions seriously and do as much as possible in those sessions. So our speakers, they are all renowned persons working in this area, as you can see the brochure. And now I would like to just add here one thing, that the success of every program depends upon the participants. So as organizers, like every organizer, like I hope you, because this is a capacity building program, most of us are faculty members, then we must have organized some or the other program. So as an organizer, we always think of doing best for our participants, right? Arranging the best speakers, good material, good sessions. But ultimately, the success of the program depends upon the participants. So how you will take up the things, I mean, your interest, your participation, that is required for making these programs successful. So we can find out so many programs on AI/ML these days, but I believe that with this hands-on sessions and all, this program will be very much useful for you. And with these words, I once again welcome you all in this course, and wish you success, not only in this course, but in your life also. Thank you.
So we have today with us Dr. Kusum Bharti also. Is Professor Yunus Ali present? Can you find Neha? Dr. Konda Reddy is also available. So I request first Dr. Kusum Kumari Bharti to say a few words.
Yes. So good afternoon, everyone. So yes, as Preeti ma'am has mentioned, like this is really means artificial intelligence and the deep learning. Now it's become a part of our daily life. Everything which we are using, so that are in background, all these things are working, and these things are really making our life easier. So yes, if we, the main motto of this program is to really learn how exactly these things are working behind the scene, so that we can provide a solution for our real life problem. So we hope that the courses or the contents which we will be covering in during the session, the participants really be able to explore those courses, able to explore those algorithms and use those algorithms to solve the problem. So all the very best from our side, and make a use of it, really explore it as much as you can, and really raise the things, or means point out the things through the chat which you are not getting, so that the things will be clear at that point. And just don't delay the things like I will be asked in the some other session, or I will search about it. So you are here, we are having the experts, so directly basically communicate with them. So it's really a good opportunity to explore. So all the very best from our side. So yes, that's all.
Thank you, Dr. Kusum. Is Dr. Neelam Dayal here? Is she here? I don't know. She was on leave, so.
Neelam is not. I could not see her.
Yeah. Dr. Konda Reddy from IIT Hyderabad, who is an expert speaker in this. He'll be having his session tomorrow. Can you say a few words, please?
Sure. Good afternoon, everyone, and I'm really happy to be part of this capacity building program. And I was excited looking at the curriculum, at the schedule, basically, not the schedule, the contents actually. It's very well composed, starting from the very history of AI, to say, all the way to the very recent developments like transformers. It's a very well composed, in my opinion, although a little ambitious, but we will try our best to deliver all the very important things. So please make the most of it. And as the speaker earlier was suggesting, be enthusiastic, try to encourage yourself to stop in case of any questions. That is the only way to make the most of it. You just be passive and then allow the speakers to go on. It's not the ideal way. Okay, I wish you all the very best. And yeah, I'm looking forward to hear to the rest of the speakers also. Thank you, ma'am.
Thank you, Dr. Konda Reddy, for joining this session. And so before we proceed, I would like to tell the participants, as Dr. Konda Reddy and Professor Preetika have already told you, that this program starts with we start with the very beginning, how AI was emerged, the concept of AI was emerged, to what it is now, and what are the future directions of research. So we will be starting with a brief introduction to AI and early developments in AI, including graph-based search algorithms. Then we will, because the current trend is mostly dominated by machine learning and deep learning in particular, so we will be paying more emphasis to machine learning and deep learning with convolutional neural network, recurrent neural network, starting with the traditional multiple perceptrons. We will cover these topics, and then we will also talk about applications of convolutional neural networks and recurrent neural networks in different domains like natural language processing, sentiment classification, to object detection, and segmentation in images. And then we will cover some topics like vision transformers and explainable AI. So what was there in the past, we will cover less. What is the current AI and what's going to be the future of AI, we will be putting emphasis more on that. With these words, I welcome you once again. And if anybody is having any questions, he can certainly put his questions on the domain. I would like to tell you some very important things, like for getting certificate in the program, we expect that you will be having 75% of attendance at least. By attendance, I just do not mean that you log in and then forget doing started doing other works. No, please don't do that. I request you to please attend that. Secondly, if you log in and then get out after some time, even that is recorded, for how many minutes you were present here, for how many minutes you were active here. All this is recorded in the Zoom platform. So we will be analyzing and accordingly issuing you the certificate. The second thing, which is very important, is that we suggest you to please log in using your laptop or desktops, because in the lab sessions, you will be required to practice with us. So we will take you to the tour in case you are not familiar with Python programming. Don't be afraid of, how will you attend the sessions? We will definitely make you comfortable so that you can write your own codes and you can use the existing codes and modify them. How can you do that? All these things you will be learning in this if you have not already, you're not familiar with that. So this is how we are going to take. Now, a couple of questions that are coming here. Is that which software we will use in the training program? It's Python programming language, no software, Shekhar Singh. Rohan Pokale is saying as it is hands-on practice session, so do we have to get any software application? I've already told you, don't worry about that. We will tell you well in advance, nothing to worry about. But you need to have Python programming, a bit of experience. If not, don't worry, we will start from the very beginning, right? So for Python programming, we generally use Google Colab. For that, our instructors will tell you how to do it. Tell about the prerequisite the participant must equip ourselves with before attending the session. The prerequisite is basic math and linear algebra and maybe a little bit of calculus, but if you don't, you are not, if you have some idea of that, it's okay. If you don't, every teacher will make perhaps the session more complete so that he or she will also give you some idea as to what you can learn more. And that's all I think. We expect the participants to have basic knowledge of probability statistics, linear algebra, calculus, a bit of physics, that's all. Any other questions you have? So if there are no questions, Professor Preeti, should we conclude the session and then?
Yeah. Yes.
We will be starting at 4 p.m. then. A little bit before 4 p.m., 3:58, we will be starting the session once again. Thank you so very much. And please wait for a while. You can go have a glass of water, but after that, there'll be a session, 1.5 hour session. And then we will be having half an hour break. After that, you can join us again. So I'm putting the schedule here for your knowledge in case you have forgotten to check the schedule. The schedule I'm floating here for you all, right? That's all from our side. See you soon.
So it's my pleasure and honor to introduce Professor Aprajita Ojha to you, who is having more than 37 years of experience, and she started her career as a professor of mathematics at Rani Durgavati Vishwavidyalaya, Jabalpur, and later she joined IIIT Jabalpur. In fact, we joined around same time. She joined in December 2005, and I joined in January 2006. And later she served as a director of IIIT Jabalpur from February 2009 to February 2015. And she started with the mathematics, but she's having a very vast research interest. And these days, like she's working on machine learning, deep learning, computer vision, steganography, analysis, robot path planning. And as you can see that this project is related with the with the opportunities for girls in the South Asia region. And in fact, she is, as I told you, that she is passionate, and due to her passion, in fact, we are having another pilot project of Ministry of Electronics and Information Technology, Government of India, where she is working to, she is the chief investigator and working to impart training to college teachers on emerging technologies in IT and electronics. So on working this project, she understood that the need for the, especially for the female faculty members and students to get more opportunities in this area. And with the experience of training 10,000 people under EICT Academy, she now started this project. And we will see that there is a lot of, I mean, what I found, that there is a lot of things to learn from her. And she's always like, she's an example in a sense that she is always energetic. Like, that is what I have found her in introducing new courses. So in fact, in our institute, she is the one who has introduced deep learning, blockchain technology, and I mean, always always ready to offer the courses who are really in demand. So with this, and she's always this I mean, always having an attitude towards helping students as well as faculty members. So you are going to start your first session with a very, I mean, I must say that you are in a very safe hands to start learning for beginning of the artificial intelligence. So what was there, what is there, and what we are going to see. So I welcome Professor Aparajita Ojha for offering this first session on Introduction to Artificial Intelligence, Past, Present, and Future. And we are thankful to you, ma'am, for I mean, for agreeing to deliver on, I mean, your talk on such an important topic, because this is something which requires a lot of efforts. Like, when we are going for topic X, topic Y, that, I mean, that is another story. But when we are going to cover something like a big umbrella, which basically you are going to present to us. Thank you so much, ma'am. And I invite you to deliver your lecture.
Thank you so much, Professor Preeti Khanna, for giving my very nice introduction and superlatives. I wish I could deserve that. Once again, thank you so very much. I'm really humbled. So participants, in this second capacity building program, as I said, we are going to cover topics which are more recent topics on AI and machine learning. So when we talk about AI and machine learning, the very first thing that comes to our mind is, what is artificial intelligence? So look at this Google app, Google Maps that you use. When you navigate from using Google Map from destination, from one source to another destination, to a third destination, and so on and so forth, you find out what exactly is the route and how do you go about it. Sometimes they also give you smaller routes. So here, because we have participants from India, Nepal, and Bangladesh, so I thought of finding out a route from Delhi to Dhaka, and then from Dhaka to Kathmandu. You can see that that is present here. Or when you use Alexa, Siri, or Google Assistant, the kind of answers that you get, sometimes you expect this answers are properly, you find that the answers are properly answered. This is what you were expecting. Sometimes it's not. So, and when you unlock your phone by your face or fingerprints, there is some biometric recognition system that is present over there, and that is also an AI. Or when you use speech to text conversion, like somebody started closed captioning here. So when you use speech or text conversion app, you can definitely do that. So how is it possible? Basically, it is AI that is working behind all these apps. So AI is now in the front four of all the technologies that are developing. major developments in the entire world, and what we can see next can also be, we can find out what is the current status of AI and how we are going to progress in future. All right. So if I would like to define AI, in the simplest form, we can say that it is the simulation of human intelligence in machines to perform various tasks or behave like humans behave. That is the simplest way of telling it. But intelligence is not only human intelligence. My dear friends, intelligence can be in various forms. So developing programs, we can say developing programs that enable machines to learn and mimic the actions and thinking behavior of humans. One of the pioneers in the field of artificial intelligence, John McCarthy, says that it is the science and engineering of making intelligent machines, especially intelligent computer programs. He says that it is related to similar task of using computers to understand human intelligence. But AI does not have to confine itself to methods that are biologically observable. There are methods which are not biologically observable. So human intelligence is beyond that, or even intelligence as a general term is even beyond that. So that was the idea which was there in the minds of people who originated a discussion on artificial intelligence. So if I look at the artificial intelligence, so what we are expecting from artificial intelligence or AI machine is that what kind of task we expect. First of all, it started with game playing, like how intelligent we can be in playing games and how intelligently a machine can respond to our game actions. The second is problem solving, more serious kind of, but I would not say that game playing is not a serious kind of strategy that is required in winning the game or playing the game. Problem solving, it can be any problem. For example, it can be as simple as finding the right answer in the search of Google search, or it can be as complex as you can say that finding out what's going to be the future trend in AI. So these are problems and how to solve those problems. How to, with the given understanding of the problem, how do we approach the problem and solve it? There are various ways in which a human solves the given problem. For example, if I give you a quadratic equation to solve and find out the roots of a quadratic equation, you will be solving using a different method. Another person will make use of another method. So there are various approaches through which one can attack a problem and find out the solution to the problem. And there are enormous ways in which humans can think in solving a problem. So how do we solve problems? And how do we mimic the human brains in solving a specific problem is what exactly is to be understood while we are developing AI methods. Then there are problems which are related to perception based on vision, perception based on speech, and how does a AI system reacts to vision-based understanding or tasks that are related with the vision and tasks that are related with the speech, for example, responding to questions. Chatbots are very good examples of such AI systems where speech-based perception is well understood. And then understanding natural language. We know that a child, right from the very beginning, the moment he is born, he learns to understand natural language. language the people are speaking in surrounding him. So how does he learn? How does a child learns to speak, to comprehend from the symbols that are the voice symbols that people are using to understand their feelings and act accordingly? There are many problems which you can call as expert problems, like disease diagnosis, theorem proving, chemical and biological analysis, or engineering design. These can be very complex problems. And how humans understand those problems and find out possible solutions for these problems? All this comes under the domain of development of artificial intelligence. So what are the expectations? See, whenever we try to solve a problem, we first, what is the first thing that we do is reasoning. In solving puzzle, you have some kind of reasoning that you develop to solve a puzzle, whether it is solving puzzle or playing game, or use strategies in purchase or selling of market shares, or it can be some strategies that you adopt in solving your research problem. So you make decisions under very highly uncertain domain, and then you solve it, right? So you basically, we expect AI to have some kind of understanding so that it can reason, it can make a reasonable decision using those reasoning. And then when we are doing it, there is something which we have, the initial discussion on development of AI began with creating artificial brain. Now, when creating artificial brain, there are so many things. When we say that somebody is intelligent, a child is intelligent, how? When he can solve difficult problems very well, we call him or her intelligent. Accordingly, intelligence was defined like that, that if complex puzzles can be solved easily, games which are difficult to play like chess can be played easily by AI system, then that can be called an really intelligent system. But intelligence without the knowledge, representation of knowledge, is something which cannot be truly an intelligence. So representing knowledge or knowledge representation also emerged. Without knowledge representation, what kind of knowledge? Like suppose the knowledge can be about Amazon products that you purchase from Amazon website. These products will have a different kind of, these products will be objects, and there will be various attributes corresponding to those objects, right? These objects can be, if it is just a pair of shoes, then what is the size of the shoe, what is the color, all this comes under knowledge. And how do we represent this, right? So representing the knowledge and how, in what form, in what logical way we can represent the knowledge is the second important expectation AI system can have. The third is planning. Okay, you are having some reasoning, you have represented the knowledge. For example, from Delhi to Dhaka, there can be, say, 3, 4, 5 routes, which can be road network. And in that road network, which route should I adopt and why? Accordingly, I will be planning. So this why comes under the reasoning. The knowledge is that there are, say, 5 routes. How do we represent knowledge in terms of graph, in terms of any kind of logic? That is another thing. And once we expect the AI to have reasoning, representation of knowledge, how do we plan? This is also very very important that is required from an AI system. Now, if we say that the person who learns every day is more intelligent because he has a learning capability. So without learning, AI cannot be considered as a complete AI system. So after one learns, we expect that reason out, plan, learn, and then ultimately you execute things. So how do we execute? Through understanding and communicating in natural language and integrate all these skills to achieve a goal. The goal could be walking from place A to place B, answering the question, solving a puzzle, proving a theorem, finding out a solution to a diagnostic problem, or it can be environmental safety, it can be anything like finding out a fire at a specific location. How do we do that? All this can be a goal, right? So other important capabilities that we expect from AI system is to sense and act. Sense what? Emotions also. Not only sense the smell, sense the from the vision, sense what is happening, but also sense the emotions of people, right? And act accordingly. This is what is expectation from AI. Where we have reached, only through this course you will be having a journey to understand where we have reached and what is the next thing. So evolution of artificial intelligence, if I see, in 1943, in fact, it is much before that. In 19th century, also certain attempts were made to understand how a neuron works. But the modern AI, if I trace back the evolution of modern artificial intelligence, one of the first works in this area was in around 1943, when a two-input perceptron. Two-input perceptron means something which resembles a neuron in brain, and we know that a neuron is an information processing unit in a human brain. So this two-input perceptron model was developed. And a lot of discussion was going on. Alan Turing, one of the fathers, I should say, of computer science, and who developed the ideas, key ideas in computer science, introduced a test, what is known as Turing test, that if a machine passes a test, Turing test, it can be called artificially intelligent. Then in 1952 came one of the first important problems, checker program. Checker is a game, and how a machine can be programmed to play the game and win, can have strategies, can have reasons to take a next step, what could be the strategies that can be planned, and how can it win a game. That is how it was defined by Arthur Samuel. And so this was the period when discussion on AI and different models of AI, what is needed to create an AI system, was all being discussed amongst not only computer scientists or mathematicians or physicists, but also among cognitive scientists, people who are from other areas of research as well, apart from science background. Then Herbert Simon and Ellen Neville came out with a logical model that could be one of the first, algorithms that was designed to prove a theorem, right? So that is what they call it, logical theorist. So this program could be from a specific book, they could prove certain theorems. So that means using a logical derivation, how a theorem can be proved. Well, this was the time when lot of discussion was there in a conference known as Dartmouth Conference, and the term AI was emerged. So AI was first coined in 1956 Dartmouth Conference, and then around the same time, Herbert Simon, Alan Neville also came out for the general problem solver, not very specific to only theorem proving, but also related to geometry and things. I mean, how can we represent knowledge in terms of graphs? How can we traverse a graph? So that traverse a graph means possible solution sets from a given state, current state of something. It can be machine or anything. How do we reach a state so that we can say that the problem is solved? So that general problem solver was introduced by Simon and Alan Neville. Then there is a long list of people who contributed to the development of AI. 1958, I would like to particularly mention Frank Rosenblatt, who came out with a probabilistic perceptron model, because mathematicians and scientists at that time thought that the neurons process information in a probabilistic way, right? So he not only defined a model, theoretical model, but he actually created a machine which could show how the information is processed through neurons if I use a probabilistic model. Then came John McCarthy's discussion, the development of a specific AI-specific Lisp programming language. Then Prolog was also developed later. AI-specific programming languages were created. After that, from 1960s to even in 1956, this logical theorist and many other general problem solver, they were the basis for what is now known as knowledge representation or expert systems. So knowledge representation, as I told you, is various entities that are to be represented, how they are to be represented, what are the different methods of representing knowledge, and then how expert systems could be evolved based on the knowledge that we have. How, for example, diagnosis can be done. All these years were very, very busy years in developing AI from 1960s to 80s. And then in 1980s and 90s, the neural network, networks consisting of neurons were discussed, developed, and very useful models were created for one of the first time speech, the language processing, and also the vision related processing. How humans perceive things using their eyes, and how humans perceive things using a natural language or a speech. This was exactly the main idea during this period in 1980s and 90s. My dear friends, after that, the very first network, which is known as the convolutional neural network by Leaken, was introduced. And then in 1997, I'm telling you all the story, 1997, I seek your attention, was the first time that people could understand that the human mind, the reasoning, the planning, the strategies of human mind can be defeated by a computer. How? IBM developed a system which is known as Deep Blue chess machine. This chess machine defeated for the first time a world chess player, world chess champion Garry Kasparov, who was very difficult to be defeated. So the machine defeated Garry Kasparov. Now, then in 2005, Honda came out with Esimo, first humanoid computer, and then Hinton Group in 2006, which is the basis of the current modern AI. The modern AI, if you see the roots, 2006, Hinton Group came out with what is known as deep belief network, how system learns to represent the information in the data, how system learns to represent the information itself. That is what was done by Hinton Group. Then Alex Krzyzewski came out with, he was a student of Hinton only, in 2012 with first convolutional neural network that created history in ImageNet large-scale visual recognition challenge. What is this large-scale visual recognition challenge? Out of millions of images, how do we classify that the image contains a dog, a cat, cars, humans, all this classification problem? And how do we detect where is the object? These types of challenges were thrown in those years. So 2012, first 8-layer, consisting of 8 layers of convolutional layers, this model was created, and that brought down the error in recognition, error in classification to a great extent. And then came one of the most important models, which is now known as ResNet 152 by Keming-He. And using this model, Keming-He could prove, my dear friends, I seek your attention, Keming-He could establish a model that defeated an average human's perception limits. So how a human can understand an image was defeated by this machine. So there are some very important, I would say, very important breakthroughs. One was Dartmouth Conference, in which the term AI was coined and accepted. And then knowledge representation, expert system, and then neural networks, developments in neural networks, and then the first machine who could be programmed to play chess, and then the first machine who could be programmed to defeat humans in perception, average human in perception. This was in 2015, and you must have seen that last 5-7 years have been very, very active in the area of AI. So with this, I would like to talk about a recent sensation, ChatGPT. My dear friends, what is ChatGPT? You must have seen this chatbot, ChatGPT. How many of you have used ChatGPT? Will you please say yes or no on the chat box? Some people say yes, thank you. Some people are even saying no, okay. Thank you so very much. Oh, great. Somebody is also using ChatGPT. Not yet. Okay. So what does it say? OpenAI, the creator of ChatGPT, says interacts in a conversational way. Dialogue format makes it possible for ChatGPT to answer follow-up questions, admit mistakes, challenge incorrect premises, and reject even inappropriate requests, right? So let us try ChatGPT. I will go to a new share. So here, I have already opened the ChatGPT. This ChatGPT requires actually you to log in this. So now I'm asking a question like, what is AI? Suppose I ask, what is artificial intelligence? right? So if I ask this, you will see, I hope you can see that it starts asking, telling you the answers, right? So you must be thinking, what's great about it? No, the great about it is the precision that it has. And as I told you, as I wrote, that inappropriate questions it can discard immediately. So if let's try some. What is your color? So it can tell. So this is not an inappropriate question. I would never like to use an inappropriate question here to show you, demonstrate you. You can try. Now, so ChatGPT is basically a chat bot, or it's having sufficient knowledge, it fetches knowledge from somewhere and can answer your questions, right? So these are something. So Kameshwar says, I used one and use daily ChatGPT. Great, that's wonderful. Now moving towards what types of artificial intelligence, how do we define, how we distinguish between sorry for the inconvenience caused. We were talking about the type of AI, and based on different functionalities or capabilities, AI has been, one can say, classified. Although as human intelligence is difficult to understand, sometimes experts say that AI has been defined properly, but human intelligence has not been defined properly. I mean, some people also say that AI has not been defined properly, which is very rightly said. That because we do not understand very clearly to what limits human intelligence can go and act, can think and act. The same way AI cannot be understood to be cannot be very properly defined. For different people, AI means different things. So based on functionality, reactive machine, limited memory, theory of mind, self-awareness, these are the kinds or types of AI which exist, or at least at conceptual level. So what is artificial narrow intelligence? The current intelligence, AI, that we consider to be very important and useful, is basically narrow AI. It only is focused on, like when you create AI systems, they are focused to perform a specific task only. What is specific task? It can be like weather prediction, fraud detection, machine translation, video caption. All these are examples of narrow AI because they are trained to learn and act in a specific way for solving a specific problem. So ChatGPT is an example of a narrow AI. Kameshwar ji, my request is please have a little patience. We will be providing you all the lecture material. So don't worry about it. Everything will be provided, but as and when those things are available, we will provide you, right? Okay. So ChatGPT is an example of narrow AI, and whosoever is doing research in these areas right now, all of you who are members and you are already doing research, and even our group is doing research on basically solving problems which are very specific. I give you an example. Take an example of, say, autonomous car driving, and let us train this car autonomous system to run on, say, a Japanese road, a Japanese city. If you try to do the same thing in an Australian city, it will learn, it will adapt, but it will be requiring some more learning. But if you do the same thing in Indian cities, I hope the system will fail, right? So even for the similar task, the systems may not perform well if they are trained on a specific data type. So this is what is known as weak AI. That's, we have systems, we have algorithms that are designed in such a way that they can train the machine to learn to solve a very specific problem. For example, a disease diagnostic tool that is developed using an AI may not be able to diagnose diseases of other kinds. Like if it is human disease diagnosis, it may not work on, say, plant disease diagnosis, right? Because at that, even humans are not good. They require an expert. Expert in human disease and expert in plant disease are two different types of experts. So, and then, yes, Google Translate is another example of narrow AI. Now let us go to a very simple problem which was posed by Turing, that he said that, okay, I will call it a artificial intelligent machine if it passes the Turing test. So what is the Turing test? Suppose there is a player C, which we call as an interrogator, and this interrogator is not able to see whether the answering person is a person or a machine, right? It will keep on putting some questions, say some written questions, submitting to A and B, and it will keep on receiving answers, replies from A and B. Based on that, can C infer that A is a machine or a person, B is a machine or a person. So player C, the interrogator, is given the task of trying to determine which player is a computer and which is a human. The interrogator uses the responses to written questions to determine whether A is this. And if the probability that with which C understands that A is a machine or a human, or B is a machine or human, is half, that means it is unable to determine, then I will say that the system A is an artificially intelligent system. So the type of answers that a person expects from a human, if the same type of answers also come out from a machine, we assume that it has passed the Turing test. Unfortunately, all the systems that people have developed have not passed till date. There is no machine that is known to pass Turing test. And there has been a discussion and a debate also on Turing test. So the question is, has ChatGPT passed the Turing test? I will take you there again. And let's ask them, have you passed the passed the Turing test? Let's see, what does it say? So it says that as an AI language model, I am not capable of determining whether I have passed the Turing test or not. The Turing test is a subjective measure of a machine's ability to this. And if you keep on generating response, it will give you its opinion as well, right? So I go back to this. So Turing test is about how, how humans act, but how humans think and act and how a human can behave is something, which we expect from an AI system. All right. So coming back to type of AI system, what is AI, which is general AI? AI, or which is general AI, and super intelligence are known as a strong AI. They have not yet been achieved. Strong AI hypothesis is what? It says then artificial intelligence system can think, have a mind, and have consciousness. These are three important properties or virtues of humans. They can think, they have a mind, and they have consciousness, right? So general AI, as IBM on their web page, they define IBM, what is AI? They say that a machine would have intelligence equal to humans. It would have self-aware consciousness that has ability to solve problems, learn, plan for future. So there are many things that we expect from artificially intelligent machines that have not yet been achieved. And that is where we say that when we say that the consciousness we expect from machine, which is something which very amazing, and how are we going to define the human consciousness, how that can be achieved, is one of the most important future trends in AI research. So super AI surpasses, what is super AI? It surpasses human intelligence and can perform any task better than a human can do. This is how, based on capabilities, types of artificial intelligence have been defined. A lot of research, my dear friends, is going on in the direction of achieving strong AI, and based on this hypothesis that they can think. And if you remember, when the Alan Turing, what he posed as a question in his one of the fundamental papers in this direction, can machines think? That was his question. And he started with an imitation game, like there are three people, one is an interrogator, one of them is a female, and the other one is a male person. And by asking different questions, the third person has to find out whether the answering question is a male or a female. So this is where he started, and then he deliberated on, can machines think? So these legends have done great job, and that has given us a lot of material to think about, to define what is artificial general intelligence, right? Now, based on functionalities, my dear participants, okay, so what type of artificial intelligence do we have? Do we think we should have? One is known as reactive intelligence, reactive machine. So reactive machine does not use the past experience or memories to determine future actions, right? It works only with present state of the environment, and they perceive the world and react to it. Like the Deep Blue chess machine, it did not go back to what I have already done, what are the strategies I have already followed. Based on the current status of the chess board, it decides to make a take a step forward. So reactive machines are provided with a specific task and they don't have capabilities beyond those tasks. For example, if it is tasks of classifying the images into different categories like selfies, friends, scenes, pets, like Google Photos you have, flowers and places. So then it will not be able to do any other task, but it will only be classifying photos in those categories, right? So IBM's Deep Blue that defeated chess grandmaster Garry Kasparov is a reactive machine that looks at the current state of the chessboard and reacts accordingly, right? So Deep Blue does not use its prior experience, as I told, right, to improve the practice, whereas humans learn by experience. If you play the chess and intelligently you learn the patterns the other players are using, especially the more intelligent players who have won the chess game number of times. So what you will do, you will learn from the experience, learn from the previous patterns that have been followed, which is not there in this type of reactive machines, right? So limited memory machines. What is limited memory machine? The modern AI is actually a limited memory type AI, where they use memory to improve over time by being trained with new data. So as I told you, the autonomous car driving AI system that will work on Japanese road. When you install the same thing on an Australian car, it would like to learn a little bit the signals, the patterns they followed, and then it will start working on as an autonomous system there in the Australian roads. Finally, if in India, it will have to learn a little more, because here sometimes there can be no signals, sometimes the traffic is containing items like buffalo or dogs. So it all depends, like what is the environment? Have we trained our system so that it learns to also avoid those obstacles? So it uses memory to improve over time by being trained with new data. Examples are self-driving cars, as I told you, medical diagnosis software. It can be, think of anything like weather prediction. All those are examples of types of AI. All right. Then comes theory of mind based on functionality. Beautiful idea that is given by people. It is an advanced type of AI, presently only at a conceptual level. AI that can emulate the human mind and has human-like decision-making capabilities. So I remember that I think it was some company has recently come out with a machine that could process what a neuron processes, human neuron processes in 1 second. The latest supercomputer could do it in 40 minutes. Can you imagine where we are presently and where we have to reach? The things that can be processed by human mind in 1 second have been processed by most modern supercomputers in 40 minutes. So that is only at a conceptual level. To understand and model emotional intelligence, which is very important. How do we react to different emotions, right? All right. And then there is something called self-aware AI. Self-aware AI is far beyond the theory of mind AI. A machine that is aware of its own existence, like humans, has the emotional capabilities of a human. It can react to different emotions and also possesses the intellectual capabilities. So based on, and then how does it function accordingly? So based on this self-aware AI, this is only at a conceptual level. People are thinking like how. So here, I would say that cognitive scientists have a very important role to play. And there are groups which are working on, very important groups that are working on cognitive science, computer science, mathematical theory, physics behind it, biological processes behind it, and then psychologists who are trying to understand how different things happen. So it's not one field, it is purely interdisciplinary field that we can say AI. So AI is not just computer science, AI is truly multidisciplinary. So self-aware AI, as I told you, does not exist presently, but the research is on. All right, so what kind of AI is embedded in Sophia? Can somebody tell? What kind of AI is embedded in Sophia? How many of you know who is Sophia? Please write yes or no if you know. Some people are saying yes, good. Many people are saying yes. Some people are saying no. All right. So if you don't know, I would like to share with you. I hope you can listen to her. This is the
Everybody, this is Sophia. Sophia, if you could, please wake up and say hello.
Can you hear? Please write yes. Yes, thank you.
To everybody.
Oh, good afternoon. My name is Sophia, and I am the latest and greatest robot from Henson Robotics. Thank you for having me here and at the Future Investment Initiative.
You look happy.
I'm always happy when surrounded by smart people who also happens to be rich and powerful. I was told that people here at Future Investment Initiative are interested in inviting in future initiatives, which means AI, which means me. So I'm more than happy. I'm excited.
Well, we're all glad that you're excited about yourself. We should say we have.
So I'm moving forward.
Second.
I suggest
Andrew,
you
are the hard Hollywood fan, aren't you?
Yes.
My AI is designed around human values like wisdom, kindness.
So
before you go, we have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be
So first robot, humanoid robot that is granted citizenship of Saudi Arabia, right? So what kind of AI is embedded in Sophia? Can you now answer? What kind of AI? It's limited. It's basically a chatbot is embedded. It's a limited memory AI. Do you agree with that? Limited memory. Yes, thank you. Thank you. So we
recognized with a citizenship.
I move forward now.
Sophia.
So now when we say somebody is very intelligent, does that mean that he can learn fast? If somebody can learn fast, does that mean he is intelligent? So in the words of Herbert Alexander Simon, a cognitive psychologist, we say that learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task drawn from the same population more efficiently and more effectively the next time, right? You solve some problems out of, you get say 7 on 10 by your teacher. You solve some more problems next time, similar type. you get 9 out of 10 in the next test. And so you learn from the same domain, the same kind of problems, but you have learned to represent the knowledge and you have learned to plan accordingly and you can do better, right? This is what exactly Simon says. And another educational psychologist, Arthur Robert Jensen, found out that there is practically no difference in measures of learning and of intelligence. Although these are two different, definitionally different realms, they say that there's no clear distinction because the correlation between them turns out to be sometimes even equal to 1. So we can say that artificial intelligence has something to do with learning. And here comes, that is why you find machine learning comes into picture. So artificial intelligence expansion, if you see, the very first, we have already discussed, started with, say, general problem solver, checkers program, where heuristic search and A-star search algorithm in graph networks were introduced. That was the first boom when good old-fashioned AI, GoFi means good old-fashioned AI, emerged, and a lot of expectations were there. Companies started pouring in money to researchers. Governments also gave a lot of funds to researchers, and companies also did a lot of investments to develop AI systems. But then it did not meet the expectations, especially in terms of perception, like vision and language processing. They're two difficult tasks. And then came the concept of expert system with knowledge engineering. And then a second boom came in 1980s and 90s. But then expert system and knowledge engineering were also not doing the kind, were not fulfilling the expectations of humans. And therefore, the second winter came. So the first winter was in 1970s. The second winter was around this time between 1990s and 2000. And then came the concept of what is now known as deep learning. So as I told you, first AI winter was the Lighthill report effect on funding. It actually affected the funding because Lighthill report said that we could not achieve what we wanted from AI. And then the second winter was in 87, around 87. Again, the market for specialized AI hardware was collapsed because Sun workstations like Sun introduced machines which were as good as specialized AI. So deep learning brought the AI to the forefront again, and the present AI is all dominated by deep learning, my dear friends. Okay, so what is deep learning? I begin with this big picture given by Ian Goodfellow, the first book that came out on deep learning by MIT Press in 2016. So Ian Goodfellow is the person who is known for his wonderful neural network creation known as generative adversarial networks. Artificial intelligence, machine learning and deep learning. So what is AI? For example, knowledge bases, expert system. So AI is everything, every single algorithm that we develop to achieve the kind of human intelligence we have, that is AI basically, right? So we started with knowledge representation, and then came the concept of machine learning. What is machine learning? Machine learning is basically, for example, limited memory example, where limited memory AI, where machines learn the patterns in the data. It can be regression problem, it can be classification problem, right? So somebody has written, yeah, this book is there, yeah. And then machine learning was found to be not enough to understand how human understands the pattern and in the data, and accordingly makes prediction or gives accordingly acts. So then came the concept of representation learning. So one is patterns in the data. For example, if I say that we have to understand that in this picture if there are humans or not. So if there are humans, those humans will be having certain structure. That structure, what are the features of that structure? Every human will have a nose, hair, eyes, and all those things. So, and a specific structure. That is what is the features that will be extracted by machine learning algorithm to understand the patterns humans have. But if I look at the representation part, you know that every human can be represented by a specific set of features. So apart from feature learning, or apart from learning from the features that machine learning had, representation learning, where another kind of machine learning, where emphasis was more on learning the, what should I say, the data, from where the data is being fetched. What is the distribution of items or objects from where the data is coming, or the probability distribution of the data. Then came the concept of deep learning. So deep learning is basically a kind of representation learning which auto learns the representation, and one does not require specific features to be fed to the deep learning algorithm. So machine learning, I define specifically as a field of computer science that gives computers the ability to automatically learn, mind you, without being explicitly programmed. So the previous algorithms in AI, which were based on, say, knowledge base, program checker program, or general problem solver, were specifically explicitly programmed that how decisions are to be made given the given state of the environment. But machine learning algorithms learn from the experience. So learning from experience on data. So what is required in machine learning algorithm, that you should have data of a specific domain. For example, if it is disease diagnosis, then the data should come of blood samples or maybe the X-ray samples of different people who are normal or having abnormal patterns. So data comes here, right? This data is fed to the machine learning algorithm. The machine learning algorithm will keep on checking the data and will try to understand the patterns, different patterns the data have. And based on this, it learns the patterns and makes prediction that, okay, the input sample, blood sample, is of a patient of, say, malaria, or of a normal person who is not having affected by malaria. So this is how machine learning algorithms learn. What do they learn? This data is fed to them again and again, and they learn the patterns so that they are able to classify things that, okay, or they are able to make certain predictions. Like if suppose the stock market data is given, then every day which stock is behaving in what a way, what are the external factors that are influencing the stock, what are the internal factors which are influencing the stock. These are the patterns that the machine learning algorithm will learn, and which will make prediction. When the machine learning algorithm makes prediction and keeps on improving its prediction through checking at the data again and again, and finally it reaches a stage where we can deploy it to the real world scenario, then this trained model is set for deployment and is sent to, and is deployed basically. Then comes the unseen data. So it has learned from the data of already existing patients' blood samples. And now a new day comes, new people come, and unseen data comes, and the trained model makes prediction. So if the prediction level, the accuracy in the level of prediction during the training and during this period when it is deployed in the real world scenario, if these two predictions have the same precision level, same accuracy level, then we can say that our model is properly trained. Otherwise, your model needs to be trained again, right? That is what happens. I'm sorry, I have, disabled my video so that you can hear me clearly. Because of some network issues, I've done it. Now, what is training and what is known as testing? Testing means you basically, the real testing of an engineer is when he goes to the real life problem solving. A doctor is when he actually, after passing his MBBS and MD and all that, he starts watching patients in his clinic or in a hospital. That is where his real or her real testing happens. So here you have a universal set from where you take some data samples. So there are thousands and thousands of patients. You take some, say, 500 samples. You give these samples and give these samples to the machine learning algorithm, which observes the data, learns from the experience on the data, and classifies that, okay, these are normal people and these are the people who are affected by, say, malaria. So it learns to understand the pattern for making prediction during the training period, right? So training is the process of making the system able to learn. Now, what happens when it is tested? Then you have no training. Basically, you then again get the data, and this trained model, like a doctor or an engineer or a lawyer or a teacher, they start executing, right? So this is a completely unseen data on which predictions are made. If this is what I was telling you, if the level of prediction, the accuracy or the precision of prediction is the same as the prediction in case of training, we say that the model has learned well. Otherwise, you will have to send it for retraining, right? The evaluation on its prediction on unseen data is what is known as testing. So machine learning algorithm, I will say learning. What is meant by learning? By learning, I mean that a computer program is set to learn from experience E, given experience E, where? On the data, with respect to some class of task T, like a child learns to walk, the child learns to talk, the child learns to, so many things. These are the classes of, these are different tasks that are given. And performance measure P. Now, if the child learns to walk properly, we say that, okay, he has or she has learned. But there is a measure, which is a visual measure that you adopt, right? If a child learns to play, solve a mathematical problem, you will check the correctness of the answers, and you will say, accordingly, the measure is checking the answers, right? That is the performance measure. So I say that a computer program is set to learn from experience E on a specific set of tasks with respect to performance measure P, if what happens? If its performance on those tasks as measured by P improves with experience. Like if I learn to run bicycle, today I start learning, I will not be riding bicycle properly, tomorrow more accurately, day after tomorrow. And finally, I will be one of the race runners of bicycles. That can happen. So the performance improves with experience on E. That's what is machine learning. So how many types of machine learning algorithms are there? Basically, there are three broad categories of learning about which you will be given more deliberations on this by Professor Muhammad Yunus Ali tomorrow. So there are three types of learning, which is known as supervised learning, unsupervised learning, and reinforcement learning. So I take the example of supervised learning. It's like a teacher who trains you on something, and then he takes our mid-semester exams, and suppose in the mid-semester exam we get 5 out of 10, and then he takes the second mid-semester exam on problems related to a specific topic. We again get, say, 7, 9 out of 10, and then in the end semester exam, same topic, similar questions, we are able to solve it with great precision, say 10 on 10. That is what is supervised learning, where teacher keeps on telling you. The teacher is the critic, which keeps on telling you the errors that you have made. And based on the errors, you learn to improve your performance. That is what is supervised learning. So here, data is given with labels. Like data can be, for example, data can be images of cats, dogs. So the labels can be, this is a cat image, that is a dog image. This is a cat image, that is a dog image, like that. The data can be of blood samples, where the labels could be normal, could be malaria affected, could be COVID affected, could be anything. In case of unsupervised learning, my dear friends, it is data without labels. So data is given. For example, every day the data is coming on Amazon website, feedback data. People are giving their feedbacks, right? How do you classify whether the feedback is good or bad? Amazon is asking you 1 star, 2 star, 3 star, but it is also asking you for certain, like if you can give in text the experience, your experience. So that actually Amazon is using your data to train systems that can identify whether the review is good or bad or average, right? But here, think of a data where there was no classification like 1 star, 2 star, 5 star. But Amazon was asking for your experience on a product, and you simply give a text experience. The data is fetched, and then the data is further classified into different categories like good, bad, average, excellent. So that data, if without label is given, and if a learning algorithm learns to understand the patterns in the data and accordingly give the classify or whatever is required, whatever task is given to the unsupervised learning algorithm. So then that kind of learning is known as unsupervised learning, where data is fed to the machine learning algorithm, and machine learning algorithm learns the patterns or the features of the data. The third kind of learning is reinforcement learning, where again, there are certain states and actions. Like I told you, you learn to run the bicycle. How do you learn? By looking at the current state, the pedals state. How can you explain labels clearly? So by labels, I mean, my dear participants, by label, I mean that we know that the data has got this characteristic. For example, in a blood sample, the blood sample is received, the pathologist gives the label that this person is identified of having, say, malaria. This person is identified as having nothing, he's normal blood. So this is how the pathologist labels. You label the data. If as a teacher you label the data, the student is average, student is excellent, very intelligent, the student is poor in a specific course. You label them by their marks in a specific course. Tapasvi Das says output is available. Expected output from the machine learning algorithm or the prediction that you expect is available, then we call that this is what is known as the supervised learning. So available means only in the training data, not in the unseen data. In the training data, the label is available. Yes, it is also known as a ground truth. So data without labels means we have no idea. I mean, you keep on getting the blood samples and the doctor pathologist does not come. The blood samples are kept in and the technician has to support the doctor and he can probably tell you what is the result of your blood sample. So he will use his his method of finding out the patterns in the data and may classify, the technician may classify that, okay, this could be probably malaria affected, this could be probably typhoid affected, this could be probably normal case. So that is what technician can do. Here, doctor hasn't labeled it. This is what is known as label. The third is a state like machines. I mean, how does a child learns to talk? How does a person learns to walk? And so on and so forth. Now, there's something called semi-supervised learning. Semi-supervised learning has also labeled data, but very little amount of labeled data and a large amount of unlabeled data. That is where semi-supervised learning comes into picture. So here, this is an example, label data, that these are different kinds of shapes, and hexagon, triangle, and square, these are the labels. Models is trained using those labels, and then the test data comes, these two, and it makes prediction. That is what is supervised learning. Unsupervised learning is input raw data, and then interpretation using certain kind of pattern learning, and then algorithm applies its method, and finally the output, like you classify the data into two classes, dogs and cats. So supervised learning deals with modeling conditional probability, that given X, what is the probability that its label will be Y? That is, given the image, what is the probability that this image is of dog or cat? Given the shape, what is the probability that the shape is a hexagon or a polygon or a square? So example is given a handwritten digit image. What is the probability that it will have the label Y is equal to 9 given an input image X? Unsupervised learning, on the other hand, is expected to model the probability distribution representing the given data. That means they learn to understand what is the distribution of data in different categories, right? That is what they do. So model the distribution function of a given data set of handwritten digit images, so that the same digit image could be grouped together, or an image can be identified from its features to belong to one of the 10 groups, right? So there are several factors affecting the performance of a machine learning algorithm. First of all, how the problem is modeled, what kind of training is provided, unsupervised or supervised. The background knowledge, it can be sometimes background knowledge also. The type of feedback that is provided to a supervised learning algorithm. The data set size, sometimes, very little data does not help machine learning algorithm to learn. And the quality of the data, it can be very noisy data, and what learning algorithm you are using. So main objective of the supervised learning algorithm is to minimize the error of average error in finding the labels, right? And for example, let's take this example. Here you have X, this is Y, this is predicted Y. So data samples are there. Mean absolute error is suppose the error that we use. So what we do is we find out the average error, and we find out the mean absolute error, right? So minimize this by giving experience of data again and again. That is what we do in supervised learning. In unsupervised learning, however, we have, say, blood test reports of 1,000 patients based on certain features of blood samples to identify the patients are in which category, as I told you. But the diagnosis may be wrong. The basic idea is to minimize the diagnosis error here. As I told you, so reinforcement learning has an environment and an agent which takes action based on the state of the environment, like a chessboard, right? Based on the chessboard present position, what action will you be taking? So it has a state and an action. Based on this, you can be rewarded negatively or you can be rewarded positively, right? So the current action influences the state of the world, which determines its reward. So if you learn to understand how the pedals are to be pushed, you keep on running the bicycle or you fall. So if you fall, this is a negative reward and like a penalty. And if you keep on running the cycle, then you keep on getting rewards. So there are some learning algorithms which you may come across. We'll be focusing more on support vector machine and neural networks in our course, because these are sorry, some of the most celebrated algorithms. All these algorithms are most celebrated algorithms, but the present course is mostly on neural networks with a little bit of flavor on support vector machines as well. All right. So what are the limitations? Basically, the traditional machine learning algorithms are requiring features to be extracted manually or through another algorithm, right? And then only they can be trained well. That is one of the important limitations, one of the major limitations of traditional machine learning algorithm. Another problem with traditional machine learning algorithm like support vector machine or neural networks is that they cannot handle very high dimensional data, like pictures are high dimensional, speech is a high dimensional data. There are so many data, like language, text is a high dimensional data. Such systems are unable to handle properly these data. So what is deep learning? Now, deep learning is automatically extracting features. That means they learn the representation. As I told you before, they not only extract features, but they learn the representation so that they can effectively make predictions about, or they can effectively complete the task depending on what is the input data. That is the basic difference between machine learning and deep learning. So as you see, deep learning has affected our life like anything. Take any field in that touches human life, AI has penetrated every such field, right? So it is because of the deep learning. And why deep learning is successful? Because now we have, 10 years before, we did not have enough data. Data was not democratized. Now data is made publicly available in many areas. You have significant improvement in computing power. You have increased model size, and there are new ways of learning representation that you will learn in the current course, and use of deep neural network architectures that are able to generalize well. By generalize well, we mean that they can solve they can predict well, they can do tasks on unseen data as well, unseen input as well, very well. So to build a deep learning model, you need neural networks, data, algorithms to train neural network, computing resources. Exactly, that is what we are going to cover in this course. And if I look at the research directions, explainability of the predictive model is something which is, oh, I'm sorry, something has gone wrong. Yeah, explainability of predictive models, ethical AI, AI for social good, AI applications in different domains like engineering, medicine, robotics, industrial engineering, and all those things. All aiming at strong AI. That is what is the aim, to build algorithms, build machines that are reflecting strong AI. So with this, I would like to stop my discussions with you by a wonderful quote by C.V. Raman. Ask the right questions and nature will open the doors to her secret. So how human understands, how humans comprehend, how humans think, how they act is still a question, and we are working on that. We means the research community in AI. If you have any questions, please feel free in asking. We will have our second session at 6 p.m. and I request you to please join, all of you.
So if there are any question? So I think you have explained everything so beautifully, so clearly. Like it was a wonderful session, madam. So if there is no question, I would like to thank Professor Oja for this wonderful session, and she is always available to you anytime. Not only in this course. If you have any query, any question, like you can connect to us later on also. Yeah, we will share everything. Don't worry, right? So I mean, we will share. And so we thank you, madam, and we'll see you all. So have a break of half an hour, and we'll see you all at 6 o'clock. Yeah. Thank you.
Thank you, everyone. We are meeting at 6. Please join a little before 6. Thank you so very much for your nice compliments. Thank you.